Hi guys, welcome back. Today's topic is types of edges after DFS traversal, or you can say classification of edges of a graph after the DFS traversal of that graph. DFS means depth first search traversal of that graph. Okay, so first of all I'll tell you how many types of edges would be there. 4 types of edges would be there. First one is tree edge, second is forward edge, third one is back edge, and fourth one is cross edge. Okay, now these are 4 types of edges. Tree edge is what? When you traverse that graph, or you can say when you are applying that DFS traversal, depth first search traversal, okay, then the edges which are member of the DFS traversal, those edges would be tree edges. Okay, next is forward edge. We will discuss all the edges with the help of this example. Okay, forward edge would be what? Suppose we have an edge E of I x y, x from x to y, okay, then that edge would be called as forward edge, in which y appears after x, means x पहले आना चाहिए, उसके बाद y आएगा in the graph. Okay, or appears means what? You can say we will consider a variable that is time variable. Okay, and when you traverse this graph, then when you discover any node, then we would notice the time of that node, starting time of that node, and you can say finishing time of that node. I'll discuss with this example. So any edge xy would be forward edge, in which y appears after x and there is a path from x to y. Okay, what is back edge? As the name suggests, backward edge. Any edge xy, edge would be from x to y, This one is, I am talking about directed graph. Okay, xy, where y appears before x. See, इसमें क्या होता है? Y appears after x, और back edge में क्या होगा? Y appears before x and there is a path from y to x. And what is the cross edge? Any edge from x to y would be a cross edge, where there is no path from y to x. You cannot come from y to x. Okay, so let us discuss these type of edges with the help of this example, then it will clear it out. See, suppose this one is our example and we are applying DFS traversal on this graph first of all. Okay, we will consider one variable, that is time variable. Okay, we will start, you can start the DFS traversal from any node. Fine, we are taking this node A as a starting node. We are starting our DFS traversal from this node. Okay, now first of all go to this node A and note the time starting में क्या होगा? 1. You can say the starting time of this node, or you can say the appearing time of this node, or you can say the discovering time of this node. Right now we are at this node at time stamp at time 1. Okay, जैसे जैसे हम आगे बढ़ेंगे time will increase by 1. Okay, now here starting time of this node is what? 1. Okay, now in DFS traversal you can go either this side or this side. See, there could be many DFS traversal of this graph. I have already discussed the DFS traversal method in the previous video. I will provide you the link in the description box also. You can check out that thing. So there could be many DFS traversal of this graph. I am not saying that there would be a unique DFS traversal, but we are taking one DFS traversal. Okay, okay. I am going to this side. You can see, you can traverse this one from this side, either to F or either to this side. You can go to B also. I am going to B. We are going to B. So we will mark this edge. Fine. Now we have reached to B, means you have discovered this B. Then time of, or you can say the starting time of this node is what? 2. We will increase the time by 1, that is 2. Okay. Next, starting time of 2 is what? B is what? 2. Now from B, where you can go in DFS traversal? We can go to C only. Fine. Now we will move to C and this will mark this edge. Fine. we have reached to C now. So the starting time of, or you can say the appearing time of C becomes 3 now. Time will increase by 1. Now from C, where you can go either to D or to E. Fine, you have two choices. Let us suppose we are traversing this E through this edge. Now we have reached to this E. Now what is the appearing time, or so the discovering time of this E is what, or you can say the starting time of E. Fine, 3 tha apna starting time would be now 4. Okay, now from E, can you go anywhere? Is there any outgoing edge? No, there is no outgoing edge. We cannot go anywhere. We cannot traverse the graph now. Now you have to do what? Backtrack. Fine. Now in backtracking, where you will go? We will go to this C. And before backtracking, we will increase the time. Okay. Now starting time of this E is what? 4. Now we cannot go anywhere from this E. So you can say this E has been finished. So you can say the finishing time of this E is what? 5. Time will increase by 1. Finishing time आप कब लिखोगे? When you are not able to move forward from that node and you have to backtrack from that node. Fine. Okay. The finishing time of this is what? 5. Now we have to backtrack. We have reached back to C. Now can you go anywhere from C? Yes, we can go to this way. Fine. So we can mark this edge and we have reached to D. Now what is the discovering or the starting time, or you can say the appearing time of D is what? 5. Then next is what? 6. Okay. 6 is the appearing time of this D. Okay. Now from D, where you can go? There is only one outgoing edge and that is going to B. Can we go from D to B? No, we cannot go because B is already traversed. So we cannot go to D. Okay, now from D we cannot go anywhere. So this is, now you can say that D has been finished, or the finishing time of this D would be 7. Now we would backtrack. And now we have reached back to C. Okay, now check out. Is there any remaining node you can traverse from C? No, this node is already traversed, this node is already traversed. We cannot go anywhere, you have to backtrack. So this is also finished. The traversing, or you can say the exploring of this node is also finished. That is why we write now the finishing time of the C, and this would be 8, 7 to 8. Now from C, we would backtrack, we have reached to this B. Can we go anywhere from this B? No, we cannot go because C has been already traversed. We have to backtrack. Before backtracking, we will, this has been finished. Then we will write down the finishing time of this B would be 9. Okay. Now from B, can you go anywhere else? No. Backtrack to A. Now from A, can you go anywhere else? Can you traverse any other node? Yes, we still have one node, that is F. So we will not write the finishing time of A because A has not been finished. Still we have some node that are yet to be traversed. Okay. Now we will go to this side. B, we will mark this edge. Fine. Now we have reached to F. What is the starting time of this F now? 9 to 10. It is now 10 starting time of F. Now next, where we can go to? We can go to G and we will mark this edge. We have reached to this G. Starting time of G would be now 11. Now from G, where you can go? You can go either to L, to H or to M. You have 3 options. You can go to any node. Suppose we are traversing this node L, we are going to L. Now what is the starting time of L? We have marked this edge. Starting time of L would be 12 now because iska 11 tha na, 1 increase hoga, that would be 12 now. Now from L, where you can go? We cannot go anywhere because there is no outgoing edge. So this has been finished. Traversing of or exploring of this node has been finished because we cannot go anywhere forward. So we have to backtrack, and before backtracking we will write down the finishing time of the cell. Finishing time would be what? 13. Now backtrack to G. From G, where, is there any node where you can go? Yes, we can go to H or you can go to M. We have still two choices. Now suppose we are going to this H and we will mark this edge. Now we are going to this H. What is the starting time of H? That would be 14, because time अपना कहाँ तक पहुँच चुका है? to 13. Now next is 14. Now from H, where you can go? You can go either to K or either to I. You have two choices. Suppose we are taking this route. We are traversing this I. What is the starting time of I now? That would be 15. From I, where you can go? You can go to J only, or you can say you can traverse this J only. So mark this edge and we are going to J. What is the starting time of this J now? That would be 16. Okay. Now from J, we are at this node na J. You can go anywhere. Can you go anywhere? No, we don't have any other choice. You have to backtrack. So you can say this node has been finished. So the finishing time of J would be 17, and now we have to backtrack. Okay, backtrack to I. Okay, now from I, can you go anywhere else? Oh yes, we can go to this one. We have one outgoing edge. But will you go to this node? No, because this node has already been visited. This has starting time as ending time. This node has already been visited, so we will not go to this node. Is there any? This has been finished. So the finishing time of this I would be 18. Now we have to backtrack to this H. Okay, from H, can you go anywhere else? Is there any node still remaining left? Yes, we can traverse this node. We can go to K. We will mark this edge and we will go to K now. Now what is the starting time of K? That would be 19, because we have time has been reached to 18. Now that would be 19. Okay. Now from K, can you go anywhere else? Yes, we have two outgoing edges, to M and to L, but we cannot go to L because this node has already been traversed. We will go to this M and mark this edge. Now what is the appearing time, or you can say starting time of M would be 20. Fine. Now check out. Can you go anywhere else from this M? Yes, we have two edges, two outgoing edges, to I and to H, but we cannot traverse this I because this has already been visited. We cannot go to H because so this has already been visited, traversed. So we cannot go anywhere else from M. This has been finished. So the finishing time of this M would be 21, and we have to backtrack. Now where we will backtrack? To K. Fine. Now from K, can you go anywhere else? No, we cannot go to L. This has already been visited. So the finishing time of K would be 22, and we have to backtrack. Now from H, can you go anywhere else? No, we cannot go anywhere else. So the finishing time of H would be 23. We have to backtrack. We will go to G after backtracking. Now explore this G also. Can you go anywhere else? Yes, one outgoing edge is still remaining, G to M. But we cannot traverse this M because this M has already been traversed or visited. Okay, so we cannot go from G to M. That is why G is also finished. So finishing time of this G would be 24. We have to backtrack. We are now at this place at F. Is there any node left which you can traverse? No, there is no node left from F you can go. So the finishing time of F would be 25, and we would backtrack to A, and finally A is also finished, and the finishing time of A would be 26. So this is the DFS traversal of this graph. Now you have to find out the different type of edges. See, first of all, what is tree edge? जितने भी एजेस आपने मार्क की हैं, द एजेस विच आर मेंबर ऑफ DFS ट्रेवर्सल, ड्यूरिंग द DFS ट्रेवर्सल जितने भी एजेस आपने विजिट करी हैं, ठीक है, यहाँ पे हमने उनको मार्क कर लिया है. दोज एजेस वुड बी ट्री एजेस. ओके, and out of remaining edges you have to find out which one is forward edge, which one is back edge and which one is cross edge. Okay, so I am just writing the tree edges. Tree edges कौन कौन सी हैं अपने पास? Now the tree edges would be, see, जिस edges को हमने mark किया है, the edges which are member of DFS traversal, how many edges are there? This one, AB, AB, BC, BC, CE, CD, AF, FG, GL, GH, HI, IJ, HK and KM. These are 12 tree edges. Now what are remaining edges? And the edges which are, you know, in this red ink, those are not under the tree edges, those are still left. And out of these edges you have to find out which one is forward, which one is back edge and which one is cross edge. Let us take example. Let us take, we are just taking this edge D to B. Now this one is backward edge or forward edge or cross edge. You have to find it out. D, E. See, directed edge है तो arrow is from D to E. Now here how you will find out? Edge अपनी क्या है? D, B. This one DB. So here x is what? D and y is what? B. Fine. आपको ध्यान से देखना आप कैसे find out करोगे. X is this one and y is this one, xy. ठीक है. Now find out x appears first before y or y appears before x. You कैसे find out करोगे? You have to check the starting time by checking the starting time. x आपका है d, y आपका क्या है? b. Starting time of b is what? 2 and starting time of this d is what? 6. Starting time of b is less. Okay. Starting time अगर b का कम है, it means what? b appears before d. Fine. It means y appears before x. और ये किस में है आपका? y appears before x. Fine. And the second condition is what? There is a path from y to x. Now here y is what? b. Is there any path from this b to d? Yes, you can go from b to c, then c to d. There is a path from here to here, from y to x. So this edge is what? Back edge. Fine. This would be what? Back edge. This DB. Let us take one more edge. Let us take this one, DE. DE. Edge is from D to E. Here x is what? D and y is what? E. Find out which one appears first. Starting time of E is 4, starting time of D is 6. Fine. Starting time of E is less than starting time of D. It means E appears before D. Right? Means y appears before x. Y appears before x. Okay. But you have to check the second condition also. There is a path from y to x. Here y is what? E. Is there any path from E to B? Sorry, E to D? No, we cannot go from E to D. There is no path. So you cannot say this one is back edge. This one is what? Cross edge. See, cross edge. Edge would be x to y, where there is no path from y to x. You cannot move from y to x. So this edge is what? Cross edge. Okay. Now let us take this one, H to F. H to F. Here x is what? H and y is what? F. Find out which appears first. H to F. Starting time of F is less than starting time of H. It means F appears before H. It means Y appears before X. Y appears before X. This is what? It should be back edge, but you have to check the second condition also. There is a path from Y to X. Now here Y is what? F. Is there any path from F to H? Yes, you can go F to G, then G to H. Both condition has been satisfied. So this one is what? Back edge. This one is also back edge. Okay, let us take this one. G to M. Okay. G to M. Edge is from G to M. Direct edge है, तो X would be what? G and Y would be here M. Find out which appears first. Starting time of G is 11. Starting time of F is M is 20. So G appears before M और G has been discovered before, क्योंकि starting time G का less है तो G पहले आया उसके बाद M आया. It means यहाँ पे G क्या है? X. X appears before Y. See, Y appears after X, or the second is what? X appears before Y. Here Y appears after X. Fine. And there is a path from X to Y. Obviously there is a path, direct path ही है इसमें, ठीक है, और ये path भी हो सकता है. This is from X to Y, and this is also not a part of tree edge. इसमें second आपका third condition क्या होगी? That edge should not be the part of tree edge. G to M ये आपका tree edge में नहीं है. So this would be what? आपकी ये कौन सी होगी? Forward edge. GM वाली क्या होगी आपकी? Forward edge. Let us take this one, this case, M to I. Edge is what? M, I. X is what? M, and Y is what? I. M to I. Which appears first? Starting time of I is 15, starting time of this one is 20. Means I appears before M. It means Y, क्योंकि I अपना क्या है? Y. Y appears before X. Y appears before X. Check the second condition. There is a path from Y to X. Here Y is what? I. Y. Is there any path from I to M? Check out. From I you can go to J, but J से आप आगे कहीं नहीं जा सकते. From I you can go to D. From D you can go to either E, but आगे कुछ नहीं जा सकते. From D you can go to B. B से आप C जा सकते हो, और D and E. No, you cannot go from I to M. So there is no path from Y to X. So this cannot be back edge. See, one condition is true, that is Y appears before X, but second condition is not true. There is no path from Y to X. So we cannot say this one is back edge. This one is what? Cross edge. Okay. Check out this one. I to D. X is what? I. This one is Y. So here also Y appears after Y appears before X, because D का starting time is 6, I का starting time is 15. So I to D, X to Y. Y appears before this X. Y appears before X. Is there any path from D to I? Can we go? Check out. D से हम E जा सकते हैं, but E से हम कहीं नहीं जा सकते. D से we can go to B, B से हम C, C से यहाँ जा सकते हैं, but we cannot go from D to I. There is no path from Y to X. So this is also what? Cross edge. This I to D. This is also what? Cross edge. So like this you can find out. So we have one remaining left, that is M to H. X to Y. Here also this Y, this is Y na. So Y का starting time is 14, X का starting time is what? 20. Y appears before X. Y appears before X. Check out, is there any path from Y to X? Can you go from H to M? Yes, there is a path. You can go to this K, then to M. So this edge would be what? Back edge. Okay, now this is the list of edges. Tree edges. Forward edges only one, G to M. back edges would be DB, HF and MH, and cross edge would be DE, KL, MI and ID. See, this is also remaining K to L. This one is also remaining. This is not under the tree edge. From K to L, X is K, this one is Y, and here what is appearing time of X is 19, appearing time of Y is what? 12. It means Y appears before X. Y appears before X. You have to check second condition. Is there any path from Y to X? Means L to K. Can you go from L to K? No, we cannot go from L to K. That is why it is known as what? Cross edge. Fine. So this is the list of edges. And the one more condition is what? Union of all the 4 type of edges would be what? All the edges in the graph. If you do the union of tree edges, forward edge, back edge and cross edge, इन सब का अगर आप union करोगे, then you will get the total number of edges which are there in this graph. Fine, you can check out this. Okay, so I'll see you in the next video. Till then, bye bye, take care.